This is a problem that we're going to use the equations of motion for rotational motion. And this problem says a wheel initially rotating at 356 RPMs slows and comes to a stop in 15.6 seconds. What is its angular acceleration? So let's go through here and let's write down the things that we know. We have initially rotating at 356 RPM, so that will be omega I equals 356 RPM, and omega F comes to a stop, so that's 0. And we know delta T is 15.6 seconds, and the angular acceleration is what we're looking for, and that's alpha. All right, so looking through our toolkit, we ought to be able to come up with an equation that allows us to calculate acceleration, like perhaps the definition of acceleration. But looking back first, we're going to need to do this. We're going to need to change this RPMs into radians per second. So I'm going to erase that and rewrite it a little more friendly for doing a unit conversion, so that we're going to take this times 2 pi radians per revolution times 1 minute on the top over here and 60 seconds over there. And so I'd invite you to stop now, pause, and do the calculation. So I get 37.3 radians per second for that. And again, here are the things we know now. So I'm using the definition of acceleration, which is delta omega over delta t, or omega f minus omega I over delta t. And it turns out we know all of those things. So omega f is 0 minus, we need to do this in radians per second, so it's 37.3 radians per second. And all that's divided by the time, which is 15.6 seconds. Plug that into the calculator and we get 2.39, and the units for that will be radians per second squared. So a problem using initial final velocity and time to find acceleration.